In this video, we'll be going over the tasks for practice 2, which are calculating exact percentiles from a simple frequency distribution with a discrete dependent variable. So a discrete, compared to continuous, discrete values are typically whole number values or their ratio data with a fixed interval. So if we were looking, example, at shoe size, and we were going from a size 8 to an 8.5 to a 9 to a 9.5, right? Those are at a fixed interval width, if you will. Thus, the values that can be collected from our various subjects for whatever dependent variable that may be, the values are set to certain intervals such that there are only a certain number of potential values that could come out of our collection. So in our example, we have a database of student fitness testing that we've conducted over the years. I've pulled out squat frequencies for this particular database, and a few of your students want to know how they compared to the students from previous years. So in our practice 2 spreadsheet, we are going to calculate the exact percentile for the number of squats that each student was able to perform. This is what our data look like. So we have the number of squats completed, and then we have the frequencies at which our students were able to complete each of these numbers of squats. So if we were looking at this one, 32 students were able to complete 19 squats in our database. We then have our subjects, or the students who kind of want to know how they compare to previous semesters, and the number of squats that they were able to complete in their fitness testing. So similar to our first practice set, we can create a cumulative frequency, but in this case we can actually add a cumulative frequency table instead of using a COUNTIF function. Now the same process would work for this data set if you wanted to create a cumulative frequency column and use a COUNTIF function to then count or calculate a percentile. That would work just fine. Alternatively, we can use a method that we employed in the lecture, where we have a cumulative frequency column, and then we start from the worst scores in the frequency and work our way up to the best scores in the frequency. So in this case, I'm saying worst scores are the least number of squats, the best scores are the greatest number of squats. So starting at the beginning of, or the worst end of our distribution, we can say that the frequency is equal to, or the cumulative frequency is equal to the frequency that exists at the lowest bracket. So that would just be 3. Our cumulative frequency from there would calculate the existing frequency of the value that we're on, plus the cumulative frequency from the category or value prior to that. So in this case, we could say 2 plus the cumulative frequency before the frequency for 9 squats. And then we can just copy this all the way down. So that way we get our total sample size, which is 350 people. Then we can calculate our percentile for each individual by taking the cumulative frequency at their squat score divided by the total sample size, and then multiply by 100 to convert to a percentage. But at 30, right, we can see 30 squats performed. The cumulative frequency was 346, so we can use that cell reference and then divide by our total sample size, which should be the last cell or box of our cumulative frequency column. Then we can multiply by 100, and we get the percentile. I'm going to change this format so that our values only show 2 decimal places. And then let's do one more example just for the sake of practice. So again, we can say equals. We look at 22. We find that in our squat, or how many squats were completed column. Find the cumulative frequency at that. Divide by our sample size. Multiply by 100. Easy peasy lemon squeezy. And this is how we create or calculate exact percentiles using a cumulative frequency column with not continuous, with discrete data in a simple frequency distribution.